continuing with videos on analytical geometry, and our next bit is the gradient. Nothing new here, you have learned it last year, but we will add a little bit to it. So imagine we have these 2 points, A and B. Then I draw a line between the two, and I want to calculate the gradient of the line. Okay? So I'm just going to pause here and hear what you've got to say. How do we... Alright, so you guys remembered well that the gradient is the steepness of this hill, or whatever we want to call it. Now, one way of looking at it is to draw this triangle, okay? And then what we've got here is delta y. What is delta y? Have you come across that delta? It's the change in the y. It's how much the y increased from here to here. In this case, actually, it's negative because it's gone down. And then you also have the delta x, which is the change in the x's. Okay? And the gradient is defined as, anyone want to try? Delta y over delta x. It's the change in the y divided by the change in the x. Okay? And the delta just means difference. So normally it's nice to write down, what does that mean? It means y at point B minus y at point A divided x point B minus x at point A. Okay? Now, there's a couple of things that can go wrong here. Mainly one, really. It's always the change in the y's at the top. Okay? So the usual, most 50% of mistake will be where people write the x's at the top and the y's at the bottom. Okay? It's the y at the top. Okay? So let's calculate it for this specific example. Okay? What's the yb and minus ya? It's going to be 1 minus 3. Remember, y is the second number. Okay? So 1 minus 3 divided by 6 minus 2, which is equal to minus 2 over 4, which is minus half. Okay? So the gradient is minus half. Okay? What does the negative sign tell us? What does the negative gradient mean? It's going down. It's going down. Okay? When it's going up, it must be positive. Now at this point, where some people get confused and say, sir, how do I know this is P, this is point B and this is point A? What happens if I do the other way? Okay? What about if I call that A and I call that B? Well, in this case, what is YB? YB is going to be 3. And YA is going to be 1. XB is going to be 2. And XA is going to be 6. So now we're going to have 2 over minus 4. It's still going to get minus half. So it doesn't really matter. It doesn't really matter what difference you do, 1 minus 3 or 3 minus 1, as long as you do it for the y's and the x's. Now, why does it work out the same? Why does it work out the same?
It's the same values.
Yeah, but why? Because, look, here, 1 minus 3 was negative, 3 minus 1 was positive, but here, 6 minus 2 is positive, and here it will be negative. So we're swapping that minus twice, minus divided by minus will be positive. It's not going to make a difference. We all right with that? Okay, let's do, I'll just pause here for a second. Okay, so we'll do one more just for the sake of it, where we've got a number that a segment, a line segment is going uphill, so our gradient should be equal to a positive number, right? Okay, so sometimes you might not have the coordinates, but you need to figure out the coordinate is 1, 3. Okay, so the gradient in this case is going to be 3 minus 0, can add that point 0, 0. 3 minus 0 divided by 1 minus 0 is going to be 3. Okay? Now, we'll leave this for here. Let's just try and just look at another graph without actually calculating it, without giving you the numbers. Which number do you think is going to be bigger? The gradient of the green or the gradient of the blue? The gradient of the blue. Okay, so again, something we learned last year. Okay, the steeper the graph, the higher the number. So if this gradient is 3, this gradient might be 2 or 1 or anything. Still positive because it's going up, but it will be less than 3. steeper it is, the higher the gradient. Now let's add to this negative numbers. So we had something like this. Okay, I'll just add one more. Just pause this. Right, so we're going to do one more calculation just to make sure you guys are right with negative numbers. Okay? So these 2 points, what will be the gradient here? Okay? The difference in the y's minus the difference, divided by the difference in the x.
2 minus 1.
Okay, so, alright, so I was going to tell you that I personally usually call this point A and this one point B. So I'm always doing the one on the right minus the one on the left. But as I just showed you, it doesn't matter if you do it the other way, it will work out the same as long as you're consistent. But yeah, I would say it's minus 1 minus 2 divided by 2 minus 1. Yes, I also said minus 1 because it's minus, but we mustn't forget there's a minus 1. Okay, that's where also things can go wrong. And then we get minus 3 divided by 1. 2 minus 1 is 3. Okay? So we get minus 1. So that's the gradient minus 1. And just like I did in the... Are we okay with that? And just like I did in the positive case, okay? Just like I did in the positive case, if I drew another line between these 2 points, which one will have a more negative gradient? The purple or the black? Which one will have more negative? The purple. So if the gradient here is minus 1, the gradient of this could be minus 2, minus 3. It's going to be more negative. The more negative it is, the steeper the slide going down. Okay? And then if I draw this, which gradient will be closer to 0? The blue or the black? The blue. The blue is still negative, it's going down, but not as much as the black, so it might be minus half or minus a third, stuff like that. Are we alright with that?
Yes, sir.
Okay, so I can put a tick for calculation, just normal calculation of gradients. Make some space here. Right, so far everything was the same as last year, but now we're going to look at calculating gradients of horizontal and vertical lines, and you didn't do that last year. I didn't do it anyway. We'll solve the horizontal, that's the easier one. So we've got a flat line. Now before we're calculating it, what do you reckon the gradient should be? It should be 0 because it's not up or down. Let's just see if that works out, okay? So delta y over delta x, okay? The difference in the y's, okay? Remember, we always do the difference in the y's first, so it's 2 minus 2 divided by the difference of the x's, 2 minus 1, we get 0, over 1, we get 0. Just like we expected. Okay? But now let's check out a line like this. Okay, that's a vertical line. And we'll choose these 2 points. So we've got, let's say, 1 minus 2, and this is going to be 1 and, let's say, 4. Let's go, what should be the gradient now?
0.
Should be 0, just like this. Any other thoughts?
Which thing?
The gradient of the black one. I mean, if this is not steep at all, which means it's 0, is this not steep at all?
No, but it's just extremely steep.
Extremely steep. So extremely steep is definitely not steep. It's very steep.
Is that the steepest possible, sir?
It's the steepest possible, isn't it? So Ollie says infinity. Let's check it out, okay? Right, so in this case, delta y over delta x. What's the difference in the y? How do I calculate the difference in the y? 4 minus, don't forget the second, minus 2, divided by 1 minus 1. Okay? So what is 4 minus 2? 6. Divided by? 0. Which is infinity. Okay, so normally for grade 10 pupils, we don't want to give you nightmares. We want to be very nice, so we just say undefined, right? But I'm a bit scary monster. You know, I do like to scare you a bit. So you're absolutely right, Ollie. Okay? It is infinity. 6 divided by 0 is infinity. Okay? We're not dealing with infinity right now. You will deal with them in grade 12. Okay? But for the test, just call it undefined. Okay? And you're right, it's the steepest possible. Okay? Steepest possible. So, what we got to remember from here, horizontal lines will have gradient. 0. Okay? And vertical lines will have gradient of undefined gradient. The biggest one you can have. Okay? Fantastic. Let's pause here. Okay, right. So for popular requests, I'm going to carry on talking and we're going to do all the work tomorrow. Okay? So now we're going to, we done vertical, horizontal. Now we're looking into this business of collinear. Collinear means points that are on the same straight line. That's what collinear means. So if I'm looking at this straight line, okay, all these points, minus 1, 0, 0, 1, 1, 2 are all in the same line. They are collinear. Okay? Now, how would I know if points are collinear if I didn't draw it on the line? Let's say I just gave you these points, minus 1, 0, 0, 1, 1, 2. How can I tell if they're collinear? Yes.
Work out both.
Both are grade and?
Make a.
How would I know if they are collinear? What will happen to the gradient? That's it, you got it. You don't need me, okay? We're going to calculate the gradient for these two and for these two. If the gradient is the same, that means on the same line, because a line, that's kind of, I don't know if the definition, but a line has a constant gradient. Okay? That's what we call it linear. Okay? So let's calculate the gradient using these 2 points. Okay? We'll give it purple. So delta y over delta x. Okay? Bit of help here, guys.
2 minus 1.
2 minus 1 divided by?
1 minus 0.
Which is 1. Yeah? 1 divided by 1. Now let's calculate the gradient using these 2 points. Delta y over delta x.
1 minus 0.
1 minus 0 divided by?
0
minus 1. Okay? Which again is 1 divided by 1, which is 1. Okay? So they're collinear. And just in case, if you really, really, really are bored, as I'm sure you are usually, and you just feel like doing maths, okay? We can calculate these using these 2 points, okay? So delta y over delta x will be, how should I use these two? 2 minus 0 divided
1 minus 1.
Which is again 2 divided by 2, which is 1. So these guys are definitely collinear. Okay, collinear points. Okay, if I have, let's say, point A, B, and C, 3 points, I want to determine if they're collinear. The formula can be m of AB must be equal to m BC or AC. If that's the case, they're collinear. Okay? Shall we just do a little example where they're not collinear? And then that's it. Okay, so just as a final example, we'll show, I've got another 3 points here, which are obviously, they don't look like they're collinear. So let's just make sure that they are not collinear. By the way, what I've written here, I realized I forgot. I said, if I've got 3 points, A, B, and C, okay, for them to be collinear, the gradient using AB should be the gradient using BC. But I also should have written that they also should be equal to the gradient using which point? A and C. So we did say it, but we didn't write it. So I've got these 3 points. So let's start calculating the gradient using these 2 points. Okay? So this is, let's call that A, B, and C. So MAB. Why, by the way, just pause here. Why am I using the letter M for gradient? Do you remember what's the equation of a line? Y equals mx plus c. And what is the m? M is the gradient. So this is just why we use it. Yeah, we're gonna get this too. No. Well, not this year. Not this. Okay, let's see. MAB. Okay, what will be the gradient here? Delta y over delta x. Help here, guys. A and B. So it will be 2 minus 1 divided by
1 minus 0.
Which is equal to 1 over 1, 1. Okay? Now let's have a look at MAC. Okay? So what will that be?
2 minus 0.
2 minus 0, okay. Divided by
1
minus 0, which is 2. And you can see the gradients are not the same. If I ask you to calculate MBC, the gradient of this line, without calculation, what should it be? Undefined. It's a vertical line. Okay, so undefined. So we definitely don't have collinear. Easy, isn't it?
Yes.
Cool. Now to you. Bye-bye.